All right. So, welcome to today's class, guys. And we'll be covering NumPy. Right. In our supposed previous class, a lot has been said about NumPy and its necessities when it comes to data analysis. So we'll be moving straight to business and we won't dwell much on details rather than practicals. So, Python consists of objects which includes integers, float points, strings, and the likes. These are all objects, all right? And also it contains containers, which is our variables. They are containers. And our variables can hold lists, can hold dictionaries, can hold sets, can hold tuples, like we learned, all right? And all these kinds of values it holds depends on what you can perform with it. All right. So what you see here on this first section of code is just a plain list and then an operation done on a plain list. All right. So we have a list first, 1, 2, 3, and the second list, 1, 4, 7, 8. Then we did an operation by saying add is equals to first plus second. That means add this first list plus second list. Then we printed the add. Now, most of you might say, oh, this add just means do 1 plus 1 on the rest. Yes, is what it means. But whatever you're using this operator for determines the outcome. All right. Now, this is a list. When you use this operator in a list, it's just like you are working with strings, adding strings to string. You concatenate. That's what the sum plus sign does. It concatenates them. All right. So if you are working with two lists and you are using this add, it concatenates the list. If it was just integer numbers, not a list, it will add them up, sum them up. But when it comes to a list, it concatenates by including the latter to the former, that is by adding second to first. So if I run this, our output will be 1, 3, 4, 6, 1, 4, 7, 8. So it's adding the second list to the first list. So that's what this operator does. Okay, it's called concatenation. Now, this is just a plain list. Now, the essence of NumPy is it allows you to perform numerical analysis or operations on lists, Python lists, dictionaries, and the likes, on Python containers and objects seamlessly without stress, very fast. That's why it provides efficiency to efficiency closer to hardware. It gives you convenience, which is designed for scientific computation, and it's always used for arrays. All right, it's known as arrays. When you hear the word NumPy, you just know they're talking about arrays. NumPy array, people use those two terms together. So we just say arrays, right? It's NumPy arrays. All right. Now, for some of you might be confused. Oh, what is an array? I don't understand what an array is. In mathematics, back in school, secondary school and high school, we are taught sets. Okay, we're taught sets. Now, a set, like I said, even in this period of class, is written as using a dictionary style to write a set. Right. Now, these values it has also comes in forms of arrays. Our matrix in mathematics, that's the one people know popularly, matrix, are also arrays. All right. So you can perform these operations there using NumPy. All right. So people will say, oh, NumPy means numbers in Python. When we say numerical Python, they are all the same thing. So it allows you to perform numerical analysis while you are working with Python list and the likes, or Python objects in general. And in order for you to use a particular library, Python is a library. Okay, I forgot to mention, is a library. All right. Same, we have our pandas, which is a library. So there are different libraries which you import when you are trying to perform data analysis. I know this was all these were said in the previous class. So in order for you to use it, you need to import it. All right. So you use the import function and import the library, the name of the library. Then you can decide to use an alias or not. All right. So imported NumPy as NP. The reason we are using alias is to make the work simple. to make the code simple to understand. Instead of writing import NumPy, then anytime we want to work, we'll not be calling NumPy.array. We just use NP. All right. Every popular program you see online everywhere, they import libraries by using their first and maybe most similar uh, initials, the way you pronounce them, NumPy, NP, Pandas, PD. So it depends on your calendar, CAL. People use those ones. People can even say CD, calendar. So it depends on what you are importing and how you want it to look like. Okay, so that's why you see we import them and use an alias to understand. So any programmer or anybody who's good with Python sees your code, he knows this is what you're talking about. All right. So you import the library Python NumPy as NP, then you use it for analysis. Now, this list we have here, this is the same list we have here. But if you look at it closely, you are seeing np.array attached to the list rather than it being single the way it is here. So you are seeing np.array. Now, what is this? Is simply telling the compiler to do is that when you get to this line of code, take this list, which is inside this bracket. .array is a method in NumPy. All right, we are taught method. So .array is a method in NumPy which converts whichever thing you pass into the bracket as an array. So np.array, it means convert whatever this is in this bracket, that's this list, convert it to an array from the NumPy library, convert it to an array, and then assign it to the variable first. So this is now first array, second array. All right. So when we perform that same operation, now in the first one it was concatenation. But when we use this, because this has been an array now, if you perform this, it won't concatenate anymore. Rather, it's going to sum up. So when you run it, it's going to sum up. It sums in this arrangement. It sums 1, 1, 1 plus 1, 3 plus 4, 4 plus 7, and 6 plus 8. So it sums that up for you. That's why you have 2, 7, 11, 14. Okay, so that's the essence of you knowing what NumPy is. All right. Now, some people might ask you, why is it useful? Yes, it's useful because it gives you easy access to use memory efficient container, which makes your programming and everything you're doing, your operation, very smooth and fast. All right. So creating a 1D NumPy array. Now, when you see a list, a single list, a list that is created, once it's there, just one single list, it is seen as a one-dimensional array. All right. When you pass it, it's seen as a one-dimensional array. Now, this is a list. Okay. As you can see, this is a list created. List 1 is equals to 11, 32, 13, 64, 85, 76, 27, 68, 79. This is a list. All right. Now, this is a one-dimensional array. When you convert it to an array, it's a one-dimensional array. Here, it was created directly because if you want to create an array, you must call the np.array method to pass your list inside and then converts it. So a variable called arrow is equals to np.array, then passing 0, 1, 2 to 9. So when you run this, automatically becomes an array. And when you print the data type, of this arrow we passed, it's going to come out as an array. Okay, so let me run this and then I'll run this. So as you can see, data type is telling you numpy.nd array. So this is an array. Okay, initially without this it will become a list, but within np.array it becomes an array. So this is a list created, and you can convert a list, an already created list, to an array. How do you convert it? By calling. Now don't forget that these values, some people might like to put these values inside this place, all right, and do it again. But since we've already assigned this list now to a variable named list1, all you just pass the list1. We know how it works. List1 is just the container, so you pass the container inside the method of the array method, and then it takes the values and converts them to an array. So by doing same, I'll do a double arrow is equals to np dot array list one. So when I run this, it's successful. So when I come and print type array, watch, is this what an ND array? All right. So that's how you perform or convert from an existing list to an array. Now this is a one-dimensional array. Okay, it's a one-dimensional array. Now let's move forward. So indexing in an array, you can index an array same way you index a list, a tuple. You can index an array. How do you index? You call the variable name and you call the index number. That's how you index. That's how we have ARR3. So ARR3 gives you what? 64, because 64 is what is carrying the index number 3 here. All right, 64. So you can also slice. Same way we do slicing a list and tuples, you can slice. All right. How do you slice? You call the variable name. Then inside the index bracket, you do your slice by calling the start point and the end point separated by a colon. So you can decide to omit the first or the last, no problem. You're going to slice like that. So here I slice the array from index number 2 to index number 6, and then I assigned this sliced array to a new variable. So that's why I see you can even slice and take your attribute and save it in a new variable, so that when you want to call what to slice, you don't need to be moving back to your initial array to go and be checking the values. So I just assign, then I run and I print it. Sliced array is equals to 13, 64, 85, 76. So these values you are seeing here is all inside this. Nothing changes from an initial array, a double arrow. All right, so that's how you slice also in array. Now that's all about one-dimensional array, like I said. So a single list is a one-dimensional array when converted. Now, how do you create a two-dimensional array? All right, that is where most of our activities will be challenged, tested. In matrix comes in two-dimensional arrays a lot, all of two-dimensional arrays. So how do you create a two-dimensional array? Now, like I said, this one is a 1D array. So I'll just do this. Let me run this. This is a 1D array. So new age is equals to this. This is a 1D array from 20 to 27. Then I converted it to, using the NP array method, I converted this list to an array, like I said. So you can check the dot shape method. Okay, you can check the shape of any array of any item. Now, dot shape gives you the size. If you're using dot shape, it shows you the size of your variable. Let me put it that way. Whatever your variable contains, it shows you the size. Now, dot shape comes in two forms. All right, it comes in two forms. That's why as you are seeing this now, you're seeing 12 comma. Something is expected to be here. This empty space after the comma. Something is expected to be here. All right. But because this is a one-dimensional array, it won't give you something here, because dot shape takes two values when it's printing, when it's bringing out the attribute. It takes the number of columns and the number of rows when it comes to data sets or dictionaries. When you're checking the shape of a dictionary, it comes, those dictionaries arrange the rows and columns. So it takes you, it counts the number of columns and the number of rows. But because this is a one-dimensional array, it only counted from this direction. So there's nothing below to count. So show that you're seeing 12 comma and an empty space. Right. So this is the shape, the size of our array is 12 length in length. I know mostly when we check the length of a list, we use len. So the dot shape is what we use to check the size of our data, any data at all. Then there we have the method called dot reshape. Now, dot reshape is used when you want to change the size of an array. Okay, we want to change the size of an array. Now this is a 1D array. Okay, and the shape is 12. So we want to reshape it by making it 4,3. Now 4 by 3 matrix, that's what we want to convert it. So we're using the reshape, we're converting it to a 4 by 3 matrix. All right, so when I run this, as you can see, it splitted this whole 12 length of values of which are arrays into three different segments, but got it, 4 different, it looks like 4 lists in one list. Okay, 4 lists in one list. That's what it looks like. All right, so that's why you're seeing it like this. So you're seeing 20 to 25, then it continued 26 to 30, we split it, 30 to 20, split, then 25 to 27, we split it. All right, so you just started cutting them after the third value. So you are telling it with the reshape that give me 4 different arrays, but with having three values inside. So that's what the shape. Now this is a 4 by 3 matrix. All right. So let's print new age. So when you print new age now, as you can see, this is the actual length of it. Is the actual length. Look at it. Is the actual length. All right. So when you do dot reshape, it shows you this. It doesn't necessarily change whatever you have. Okay, it don't change it. Dot reshape does not change. Doesn't change what you have on your variable. So that's why we printed it to still have this length. Okay. So now here we are creating a nested list. Now this is all about creating 2D arrays. You convert a single array to look like a 2D array. Now you are creating nested list. The nested list is a list inside a list, like I said. That's why I said this one is looking like 4 lists in one list. If you look at the brackets, you will see them well. Look at the brackets, you see them well. So here now we are creating 1, 2, 3, 4, 5 lists inside one list and assigning them to a variable called age. All right. So then we converted this list, nested list, to an array. So when you run this, successful. So when you go ahead and you print age now, go ahead and print age. So when you go ahead and print age, or let's call age, when you call age, as you can see, look at it, array 20 to this 1, 2, 3, 4, 5. So that is it is. Now if we say array age dot shape, let's call it dot shape method. As you can see, it's now showing me 5,3. Don't forget that initially this one was just 12, nothing because it was a 1D array. Now this one is a 2D array telling me 5 by 3 arrays. So 5 rows, 3 columns inside. So this is how you create a 2D array from a nested list too. Then you can index the same way we did do nested indexing in list. If you want to index in an array like this, you have to nest it too, because it has 5 different 1D array. So in order for you to use, they need to call their index number. Each of them has their index number, and within those index number, there are other index numbers to call. So you need to do the nested indexing, which is here. So I said print age, then I called my first index, get me the values that are index 1, and within that index 1, get me the value with the index 1 again. So it's going to look at this whole list. Now from here to here is index 0, here to here is index 1. Look at the bracket. So the next one is index 2, the next one is index 3, the next one is index 4. So I'm telling it, go to index 1, which is this from your initial list. Now within this index 1, this first one is index 0, this one is index 1, this one is index 2. So if you are not calling the value, when you run this, the output will pick. After running, you see it's going to pick 29 because it's the index 1 inside the index 1, as is nested indexing. Okay. Also, you can slice. Same we did here, as you can see. can slice. Now we sliced in this way. Okay, you can slice. Now I'm telling it to get me the beginning of my age. Okay, get me the beginning of my age. Then when you are moving from this place, from the beginning, when you are moving and you get to the next comma, that's what I'm telling you to do. And you get to the next comma, because I separated it. Look at it. From here to here now, it's supposed to be the full list. Okay. If I remove this comma here now and I put this bracket here, I'm indexing beginning to end. I didn't specify, so it's supposed to give me the full list. Then I said, when you are trying to get me the full list, just take number 0. Take in number 0. That's why you're seeing 20, 60, 33. You're not getting 25, 30. You're not getting what? 25, 30. Because you are using it to jump. Look at it. 20, 26, 33, 25, 30. And look at it well. Where are you seeing this thing? 20 what? 26, 33, 25, 30. So I'm telling you to get me the index 0 of every, as I say, watch the comma. What I'm simply, this is like writing the code as, I'll put a bracket here. It's like putting a bracket here. Okay. Then I put a comma and then I put another bracket here. This is what it's like doing. But if you do it like this, it doesn't work that way. Okay. Look at it. It gets me the first, or the whole list, but it's not adding 0 to it. It's not supposed to work that way. Okay. So that's what, like I said, we are trying to do. We are trying to tell it that get me all the items, all the values in the array from beginning to end, but I need just the one with the index 0, just the ones with the index 0 in every items. So that's why I said it's a nested list. So when it's going through all the list, it's going to pick the numbers with the index 0 alone and bring them up. So if you put it like this, it won't work. That's why it is all placed in one bracket. Use a comma to separate everything, then you specify the index number 0 that you want to get. So when you run this, you are getting the first values in each of the nested list. Look at it. Don't forget this is an array. So it's getting me the first values in each of the columns, which is, let me call age. Let me call age again here so that you will see what I'm talking about. We'll move age. So let me call it. So it's going through this list 1, 2, 3, 4, 5 and getting me just 20, 26, 33, 25, 30. Now let's say I want to get all the values in the second row. All the values in the second row. So I will say index 1. Now when I run this, as you see, it's getting me 23, 29, 37, 26, 31. So if I want the index number in the last, I'll just say 3. I'll say -1, which also works. I'll run it. So it's going to give me the last item of every values in that last row, as you can see, guys. So you can do indexing like this when it's nexted. So I've checked for the shape and all. Now you can, now all this we did was creating 2D arrays from nexted list. Now you can initially just create 2D arrays directly rather than doing conversion from an already existing list. You can just pass everything, all the list you want, the number of dimensions, the number of values you want. You can pass it inside your line of code. So here we are saying matrix is equals to np.array. Then inside the round brace, we are calling our nested list. Okay, that's how you specify your length or shape of your array. As you can see, it is, this one is one list. Oh, sorry. This is one list. separated by comma. This is another one, this is another one. So 3 lists in one big list. So this will now turn out to be a 3 by 3 matrix. So let's run it. So this is a 2D array. Now this is a 3 by 3 matrix, 3 rows, 3 columns. All right. So that's how you create 2D arrays. So if you check for the shape of this, you're going to see it's a 3 by 3 matrix. So like I said, you can slice through. That's what I just did for you. So I'm slicing through this. I'm saying get me element at row 1, column 2. So element at row 1, but column 2. This is column 2. Get me the value there. All right. That's okay. Sorry, row 1 and 2. Okay. Sorry, this is supposed to be column or index 2. Row 1. Okay, column 2. Yeah, sorry, column 2. This is row 1. And this is column 2 in row 1. This is column 2. So it's getting me the index number 2. That's why we have 26 here. So it's getting me 26 in row 1. So it's going to assign row 1, which is this. This is 0. This is 0. This is 1. This is 2. Index it. So on this one, get me the item here. That's why we have 1, 2. So you can play around with your code to get different values in between. And I did that at the top before. So also you can slice the first row, which I did initially. So where I slice the first row, I slice the second row, I slice the third row. So you can do that as well. Right, so this is for the first row. Now, this is like a reverse of this. So I'm not going to explain that. This is like a reverse of this. So the minus, this was brought forward, then this also at the back. So this is what is happening here. So it's a reverse of that one I showed you guys. So that's why I say first row equals to matrix. It's calling the first row 0. Then it's telling to give you all the items on that first row. And the first row is 0. Don't forget the index number is 0. That's why you have this. So if you want the second row, you do the same thing. If you want the third row, you do the same thing. All right? Do the same thing. Oh, sorry, this is not supposed to be here. Let me remove this. Now, okay, we've checked for the shape of this. Check for the shape. This one is for the one-dimensional array created. So you can check for the shape of the 2D array, which we already did. Matrix.shape is what used to check for the shape of a 2D or 1D array. Okay. So you can also check for the data type of the array as usual. So for the okay, we're coming, guys. All right, so you can check for the data type of the array. Now, to check for data type of any array, that is, data type means you want to check the kind of values it has. D type is what you use to check for data type, right? Type is what you use to check for the kind of variable you are working with. All right. Listen attentively to these two different ones. To check for the type, let's say you want to know if it's an integer, of you want to check your variable or your values. If it's an integer, a string, a float, a boolean, you use the type. If you want to check if it's a dictionary, a set, a tuple, or a list, you use the type. That one shows you the kind of list you initially created by assigning the values. Now, if you want to now check these individual values, what kind of data type are they? Now, don't forget that a list can have different kind of data types, but D types works mostly on arrays and dictionaries. Arrays and dictionaries, okay? Not floats, not lists, not sets inclusive. It only works on arrays and dictionaries because it checks individual values per columns. It checks them, rows and columns. This row, what values are inside? The other row, what values are inside? Then it uses this kind of values to ascertain the total kind of data type it has. Now, if yours has only numbers, the data type will be integers, like we are seeing here of 1D array we initially created. Let me do that of the 2D array so that we know we're working with 2D arrays. Now, because of the values we had, everything were integers. That's why we see int 64. Don't forget about the 64. That's just the size of the bit of my system. So 64 int. That's how you check for the D type. Are we together? Now, if your values are in floats, let me say the row has floats, your array has float, or your data set has float in that particular column it has, it's going to change to float. Some will be int, some will be float. We will get to understand this a lot when we move to pandas, because they will be analyzing a large data set, not a simple array. Now, if it's just whole numbers, it will be integers. But if it is just floats, point, decimal numbers, it will be floats. Then anything aside from integers and floats are categorized as objects. Whether they are strings, special characters, true or false, they are categorized as what? Objects. That's why we said Python consists of objects, which can be numbers, strings, booleans, or whatever. They are all objects. But integers and floats are categorized separately by standing alone, because those are what you can perform analysis on, numerical analysis on. You can't perform numerical analysis on letters or logical results, but just integer values. Okay. Then we also have data type date time, which is used for any time variance column or values we have. But all of them are seen as objects. Sometimes we do conversion to make sure we are working well when we are doing some time series analysis. Okay. So to check for the type, okay, the type of variable, you use the type. To check for the data type of values, you use the D type. That's why you see D type, data type, short D type. Okay. But for just the type is TYPE. But for the data type is DTYPE, D type. Okay. So don't mix this up. Right. So also we can find the number of dimensions, in an array. Now, this is a 1D array, like I said, 1D array. Okay, number of dimensions means kind of array you are created. If it's a 1D array, 2D array, and the likes. So to use the dimensions, you call the method ndim. Ndim. Any means number, dim means dimension, number of dimension. You can see that Python is just language abbreviation. So array.ndim is used to check for the number of dimensions. Now for the one dimensional array we created, a double arrow, look at it, it's telling us it printed the whole, we told it to print the whole dimension, the whole array, then print the dimension, as you can see. So it gave us the number, any number value, integer value, and dimension. So let's do that for the other array we created. As you can see, it's telling us 2D array. It's telling us 2D array. All right, so let me print matrix dot end. Okay, let me print matrix here. So you see that it's the matrix. Let me print matrix in this box. Okay. So let me print matrix in that box. So as you can see, I printed all my matrix and then gave me the dimensions. Some of you might be saying, sir, but this is a 3 by 3 matrix. this is a 2D array. Whether you write it 5 by 5 or 4 by 4 is a 2D array. All right. The 5 by 5, 4 by 4, that's just your size of your matrix. Okay, so these are you check for the number of dimensions you are using as your array. Now, let's talk about NumPy methods you could use in NumPy. But before I do that, let me give room for some few questions before I move down to methods. So if you have any pending questions so far with what we'll be learning, just raise your hand and let's do that in the next few minutes, and then we move ahead. So I'll mute your mics now. Please, once I start taking questions, I won't accept any. So it's best you raise your hands now. Once I'm done with the people I have, any raising their hand, you will take a question to the group chat and ask your fellow people. Thank you very much. So on my queue, I have Jill. Jill, Mrs. G or Miss J. I think I've forgotten your initials. Miss Jill,
Good evening, sir.
good evening, ma'am.
There's the question I want to ask. Like when you did the matrix, the shape. So
Okay.
yeah, sorry, the reshape actually, the reshape. So I
Yeah.
wanted to ask because normally from I think mathematics, usually the first number in the bracket is usually the x, which is the horizontal. It
Yes.
seems it does not follow that way. It's usually the opposite.
Come again. You said the first number in what?
Like in mathematics, in those
Yeah.
that square bracket, the
Mm-hmm.
first one is like the x-axis, while the second one is the y-axis. Because the x is the horizontal, while the y is the vertical. It seems it's the opposite here.
Okay. Now we know x and y axis. We use that for graphs. Don't worry. When we are doing graph, you'll see x and y axis also works here like this. But when it comes to matrix, program compiler reshapes values based on. I'm trying to go to that place. It shapes values based on what you're counting, because what you see here now, you are telling it that you just have to specify. You are telling it that give me four uh 4 rows, but I need, guys, separate this my list now, my full length of list, separate it into 4 segments, and these 4 segments you are separating it should have three values each. That's what you're just telling it to do. Okay, that's why it will count the first 3, that's 1, count the next 3, that's 2, count the next 3, that's 3, count the next one, that's 4. So if you increase your number, it's going to show. So maybe if you want a 3 by 4 matrix now, you just come here and put a 3. You come here and put, sorry, you come here and put a 4. But be mindful when you are doing this. Watch the result. Be mindful when you are doing most of this. Now, as you can see, it gave me a 3 by 4. All right. So it's going to count based on this. Is I need a 3. That's a 2D matrix having just 3 rows and 4 columns. So that's what you are simply specifying. Okay, so like you said,
So
it's like calling the y first before the x.
all right, sir.
And so it
Thank you.
doesn't follow that principle. All right, thank you. So let me go to the next question. Who's that person? Next person is okay, I'm only seeing Kisley. Kisley, what's the question?
Good evening, sir.
Good evening, sir. We can't hear you if you are speaking.
My question is apart from a one-dimensional array.
Yes. Hello.
Hello, can you hear me, sir?
I can hear you.
Hello, can you hear
We
me?
can hear.
Okay, my question is apart from one-dimensional array and two-dimensional array, is there anything like three-dimensional array? That's my question, sir.
Okay. When it comes to when you're plotting your graph now, or let's say when it comes to mathematics, anything aside from 2 dimensions, you are modeling. I don't know if you've heard of the word modeling before. You are modeling, okay? When you get 3D, that's why if you're using your art, you're doing your artwork, you're seeing, you are modeling. Even the games that are being built are built in 1D and 2D, mostly 2D. If you're using AutoCAD, it is 2D. It's when you're now modeling these things you have drafted, because you must draft the plane structure, the floor. That's why your house plan has a 2D. That's how you want to use to work. Then when you are increasing your building, when you want to now see how the building will look like, you now model it with it into 3D format. So it is 1D and 2D alone. That's how computation works. Anything aside from 1D, 2D, you are modeling. Okay, that's why when you have 3D dimensions and modeling, you go to your Microsoft PowerPoint, you will see them. When your text are written as 1D or 2D, then if you want to go and format them by putting shadow, increasing the size and the length, that's now you using 3D diagram, 3D structures. So 3D is not in every section that involves programming, because all your apps you are using are built on the same platform. Okay, mostly when you are doing anything possible with it, so it is mostly on 2Ds. That's what all platforms use, is 2Ds. 1D is just like a string of text. 2D is like a combination, showing you this thing is more than one. Okay, so 3D is now you modeling your 2D. That's what is being used. Maybe you might research and you see what I'm talking about. But when it comes to computation, it is just 2D. That's the limit you get, 1D and 2D. So nothing like 3D. 3D is modeling. If you see anything 3D, in bracket, they will write modeling, because you are now building what you've laid your foundation on 2D as, right? So that's why I said, even if it's a 3x3 matrix or a 4x4, people will think 2D is a 2x2 matrix. No, even if it's a 6x10, it is a 2D matrix, because you're talking with numbers there. And so when you're now modeling, you're trying to build an app, I know you're not doing 3D and the likes. All right, thank you.
Thank you.
Okay, so let me mute all your mics back, and let's proceed to the next part of our class. I think I was okay, NumPy methods, good. So let's bring our matrix down. Now these are matrix. Okay, let's talk about some methods we can perform with NumPy. So get a hang of it, because this is necessary before we start analyzing data, because we call these methods. Like our lead instructor said, you import some libraries when you're working with data, when you're doing data analysis. The major ones you import is NumPy and pandas. NumPy and pandas is the major ones you import. Then maybe when you're trying to include other things, then you import some external libraries, some libraries like the calendar, the of one JSON. There are different libraries you can import, but basically when you're running analysis, you work on NumPy and pandas. All right. So maybe when you're not doing something different, maybe you're building something, doing data science, you can import other libraries that will assist your work in Python. But majorly it's NumPy and pandas, and you need to understand their methods. Okay. So now what are the NumPy methods? First of all, these are metrics. Okay, so let's look at the picture very well, and then we move ahead. So next thing is first thing is you can sum. Okay. Now, aside from using the plus, the 1 plus 1, this plus this, that plus that, you can use the dot sum. Okay, you can use the dot sum method. All right. That's why even when there was a time you were doing arithmetic operations, you imported the math library and you were calling some methods inside the math library. Okay, so the math library is also in NumPy. All right, so that's why you see you can call dot sum and the likes. So dot sum is a method to sum values. So sum of all elements. Now sum of elements sum everything in total. So sum is equals to sum arrow is equals to matrix dot sum. So we are printing it. So when I'm printing the sum of all elements, I'm going to get 413. So dot sum sums 13 plus 17 plus 43 plus this plus this plus this plus this plus 59, and you get this. That's how the dot sum works. All right, that's how dot sum works. So don't forget, if you want to add two matrices together, you can do the use the sign by creating two matrices and then add them together. You get, but when you add 3 by 3 matrix, you get 3 by 3 as a result. The normal matrix calculation we are done to school. So you can do that with the normal operators of the plus sign and the likes. But if you want to sum the total, you want to get the total number of values there. That's with the dot sum method in general. So these are mostly useful when you're working with, when you're analyzing data like this being set, but you need to understand all this from NumPy so that you'll be asking where we are getting these methods from. It's from NumPy. So sum of all elements is 413. Then this is our matrix again. Now you can sum by row to create a 1D array. You can also sum by column to create a 1D array from a 2D array. Right. So now as you can see, we are summing. Matrix is equals to matrix dot sum. Now dot sum is the method. Now we said inside it. Now this one without anything. Now matrix dot sum is to sum everything entirely. Okay, all the rows and columns, combine them and sum them together, all the values in that matrix. No matter how long or the size of it is, sum everything together. That's how you do it. Now, in order for you to be specific, like I said, you want to sum by row or by column. You call the axis and you specify the number of the axis you want to call. Now, this number you're specifying is the index number. Don't forget, it's the index number you're using. So go and note the index number. Matrix dot sum axis is equals to 1. Look at this place now. We have our what? Axis 1, so which is by row. Now when you run this, it's going to add everything. Look at it. After adding it, it formed a new formed a new 1D array. Now what it does, what it do this. They added all this one, gives you 167. Added all this, gives you 173. Okay, that's how it added by using individual and individual axis. Now this is you adding by separate rows. Now how do you add by columns? It's the same thing. Now by rows you say 1, by columns you call 0. Now how do you do this? You run this, you see what it's going to do. So 64, 21, 128. So initially it added like this. So it added it to sum by axis 1, that is by row. It summed horizontally. Now when you are summing by column, it's summed vertically. So 13 plus 85 plus 66 give you this. We know we do all these mathematics in all these operations in matrix in mathematics. So 17 plus 56 plus 48 give you 121. Then the last one gave you 128. So let me print the matrix again. So that's how you sum by row and by column to create a 1D array. You can assign all this. Don't forget, you can assign this to a variable. Just put a variable there and put an equal to sign. So whatever operation you perform will be assigned to that variable. So you now have your result outside. All right. So you can check for the minimum and the maximum element in your array. You can also check for the minimum and maximum element in your array. How do you do that? You call the min and the max method, dot min, dot max. It's just plain English. Minimum, min, max, maximum, max. So I'm calling it the same matrix. So I want to get the minimum value in the entire matrix and the maximum value. So I'm going to run this. So as you can see, the minimum value is 13, which is this, and the maximum value is 85, which is here. All right. So it's going to go through all the list and pick these values. This is the mean and max. So get the minimum number, the maximum number. Maybe you want to check for the person that has the minimum salary or the maximum salary. These are the methods you call. And you must call the column that has the name, or like in this case, the array that has these elements. Also, you can check for mean, standard deviation, and variance. Mean, standard deviation, and variance. Now, the mean is summing everything and dividing it by the total number. All right. So standard deviation is the variance. So let's run this and see the output. So now for the mean, dot mean, you call dot mean, you get the mean, which is 45.8666. Standard deviation is there, which is this 22.4422 and the likes. Then variance is also there, 503 and the likes. Now, these are statistical analysis, all right? I know we were talking about error and this and that, and yes, you can still use Python to perform statistical analysis, all right? But the programming language error, and that one has much more operations when it comes to statistical analysis in its own. Okay. But you can still use that to mostly when you're going to machine learning, that would be very helpful. When you're going to machine learning, it's very helpful. So like I said, to check for the mean, standard deviation, and variance, you call it dot mean, dot std, and the dot var. Right? Those are the methods you call. Please don't forget the brackets are necessary. As you can see, what I'm putting this, my few messages outside this bracket we are putting here. There's nothing inside now. Why not remove them? Don't remove it too. You can remove it and solve your error, but it is necessary because you are calling methods. That bracket is what initializes the method. For a function that has this bracket, like our print, the bracket initializes the function. Some functions don't have, some methods don't have. Those ones you don't need to, they run on their own. When you just run it, it will run. But these ones that have brackets, the brackets are necessary because it is what initializes that particular operation, whether it's a function with a bracket or a method with a bracket. A function with that bracket, like the type, you can use that. A method with that bracket, like the shape, you can use that. Okay? But when it has a bracket, please, you must put the bracket. And there are some methods which require you to specify values, like the dot reshape. When we called it, we have to specify what we want to shape as. Without you specifying, you're going to get an error. Okay? So I know we didn't try it, but you can practice that at your leisure time. So don't forget the brackets are as important as the method you are calling. All right? So now, okay, sorry, this one is just to create. This is just to create an array having elements of 1 1 1 1 each. Okay, and this one is to create an array having elements of zeros. And this one is to create. They call it dot I. It looks like I. Nose and nine, nose and nine. So it's just like telling you 1 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 1. So it's just like looping. Anywhere it sees one, it fills one, put 0. If one is appearing, so that's why you are specifying 4. If you want it to reduce it to 3, reduce it to 3. So this is just me playing around with the code. So I just created I had to create it and just play with it. Also check for the kind, but this does not affect our matrix because it's not inclusive with the matrix. We just have some other minor methods, but we don't actually use them for analysis, just to maybe play around, test some theories and all. So okay, I think this was me reshaping the array. If you want to reshape, like I said, you can reshape your array from a 1D to a 2D. I know we've done this before. So dot shape is a method, dot reshape is a method that you can also use in NumPy. So also you can perform computations like we did it at the beginning. You can also perform computations. Now we have one array, two arrays. Like I said, you can add them. If you add a 3 by 3 matrix to a 3 by 3 matrix, you're going to get a 3 by 3 matrix. Okay, it works with one to the other because the first one you are using is what determines how your output is going to be like. What determines what your output is going to be like. You must work corresponding to the size. So this is a 1D array. We want to perform an arithmetic an operation there, numerical computation. Now, let me ask a question. Let me unmute you guys, because now is an interactive class. When I ask, you respond. You must respond. Your mics are unmuted. So when I ask a question, you respond. All right. So let's proceed. Now, guys, this double asterisk, what does it mean? Double asterisk, what does it signify?
Exponential.
Signified
Exponent.
exponential.
All right, thank you very much. So it means exponential. So we're telling the program that array 1, array 2, give us a result by using array 1 as an exponential of array 2. That is array 2 raised to power array 1, and then print it out. So when you do this, watch the result. It's going to come out as a 1D array, like I said. So you are seeing 4 raised to power 1, 5 raised to power 2, and 6 raised to power 3. That's what you have here. 4 times 4 times 1, 5 times 5, 6 times 6 times 6, and the likes. So that's exponential for you. It comes out here. Now, this is our division. I know we all know this. So you run this, you can also divide. So that's why we are having point, 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 point. Now, if you check for the D type of this, you will see it is no longer int. This one will be int, but this one won't be int because of the division operator we are using here. Because that's why you see 2 point, 4 point. Now, 4 point, because of the division, you see 4 point, 4.0 is what's supposed to be here, but it's in the program just ignored the 0 and left 4 points so that you know that it is a decimal number, not 4 full stop. It's 4.0. Okay, then that's why we have 2.5 after dividing 5 by 2. Then after dividing 6 by 3, we have 2.0. So float point is in decimal number, whether it's 5, one figure 5, you write 5.0 and the likes. So 0 must be included. That's why you're seeing the point here. So this is multiplication. So you can run this. So multiplication is 4, 10, 18. So you're simply turning it to 4 times 1, 5 times 2, 6 times 3. So 18. All right. So this is just you putting the two arrays together. Then okay, now you can even combine two arrays to one by not using the addition. So this is matrix 3 is combining. Now these are two different arrays on their own, but I'm not using them to form a 2D array. Initially they are just 1D arrays, but I need to form 2D array. How? I pass them inside a cell. Now if I'm not passing the variable name, I will put these values separately inside here and put a comma. So it's just this one is representing this is representing this. That's why we have 1, 2, 3, 4, 5, 6 as the 2D array. Okay, so that's how you can perform. You can even do the modulus. You can do modulus of the array. You can do floor division. You can do anything that involves computation. You can perform it here. Okay, that's what NumPy gives you the ability to do. Okay, so we have what we call vector arrays. Vector arrays. Now, vector arrays is mostly used when you are performing analysis based on let me say monetary values. Okay, monetary values, a very large value. Okay, seen as a vector array. All right. Now, vector arrays are mostly one-dimensional. Okay, so salary is equals to np dot array. Then I called large values 45,000, 32,000, 73,000. Yes, then performing operations on this now. Now, these operations I'm performing, please look at it very well. Oh. These operations I'm performing now here, they are not the same as this. This one I'm using an array to an array, like you're adding matrix together. Now I know we were taught vectors of matrix and the like. When you're not putting using external values to do subtraction within a matrix, let's say you're doing you're using a fraction to multiply a matrix, or you're using a whole number to divide an entire matrix, you're not performing what we call vector matrix. You are doing vector analysis on it. Okay. Are we together? You can perform a vector. That's how vector works. Introducing a single value that is not of a matrix but a number inside your matrix by using it to perform operations. I know if we are doing identity of a matrix and the rest in secondary school or in primary school or in high school, those are vector analysis of a matrix. So yeah, we call them vector arrays. So this is an array like I declared. So I'm going to subtract 200 each from this salary. 200 each, because that's the vector of it. So as you can see, to subtract 200 from every value in this array. If it's a two-dimensional array, to subtract 200 from everything and print out the resulting value is vector analysis. So you can also perform some other operations, like here I'm saying salary plus. Now, the initial salary, which is 45 and this, I said carry that salary, then take this other salary and put a 2% discount. Is it 2%? Yeah. Okay, no, 20% discount. Yeah, that's multiplied by 0.2 on this. I want to get the 20%. Now, when you do 20% discount, is 0.2. All right, 2% is 0.02. So this is a 20% discount. So when you divide 20 by 100, you get 0.2. So I want to check the discount of it and add it to the salary. That's what you are saying. When you do this and multiply 0.2 by the salary, that is 45,000 times 0.2, 32,000 times 0.2, 73,000 times 0.2. Then add your answer to salary. That's why you see for 45 we had 54,000. From 32 we had 38,400. From 73 we had 87,600 because we've added the discount which they got. Now don't forget this dot you are seeing, it is coming here because of this number 0.2. Like I said, means 20 over 100. There's a division. That's why you have 0.2 float. So when you use this to multiply this and then you add it to this, the decimal point affects everything. So it changes your integers to floats. That's why you're seeing it now. There's a point attached. This means there's a zero at the end of the dot and for every value. So these are vector analysis. So you can do that. You can even rearrange. Let me see which one is this one. Okay, this one is a different. Okay, now new array is equals to np dot arrange. Arrange is a method. 1, 15, 13. So 3. Then we need to rearrange these values by 1, 15, and 3. Now this is like giving it a how will I explain this now? All right, so this is like giving it a range. Yes, this is a range. Yeah, like I'm generating random values using a range. Now we explained a start, a stop, and a step for you guys. So this is start at 1. I want a single array of 1 to 15, but I want it to be increasing them by 3. So that's why it started at 1. 1 plus 3 is 4. You get me? So the number will not exceed 15. You get me? So the last number will not exceed 15. 1 plus 3, 4. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. Now, if you add 13 plus 3, it will be more than 15. That's why you're seeing 13 here. So I'm just generating random numbers here. As you can see, you can generate by using the dot what arrange. Okay. You can generate numbers using the dot arrange. All right. Then this is me doing adding 2 to each of these array I've done. So I'm just performing vector analysis on them. That's why you have 1 plus 2, 3, and the likes. So it went back to 15. Then I think let me not continue with this so that we won't prolong our class. Also, you can do Boolean arrays. All right. Now, Boolean simply means true or false. I know we are taught what Boolean data type is, true or false. All right. So we call them Boolean array because when you are using it to test for logical testing, you want to see, you want to filter, you want to check if this value is this value is this. Your answer comes out. Your answer comes out in Boolean format. All right. Now these are. Oh, sorry, I didn't declare this. Let me use Let me just declare. Let me run this. I didn't want to run it before, but let me run this. Okay. I didn't want to run this before, but like this one now is used to generate random numbers on a one-dimensional array. Now this one is for a two-dimensional array. Okay, as you can see, look at it very well. It's the same NP arrange I used. I said the first one gave me numbers from 1 to 6. I didn't put a step. Then I separated with a comma. Don't forget this one now is 1. Then I separated with a comma to get another kind of range arrays. Okay, that's what I just did. That's what I did here. Okay, that's what I did here. So I did everything and then I said make them an array for me. Simple as that, like this. Okay. So that's why I have the two-dimensional array here. I didn't want to do it before, but no problem since it's here. So let me bring it down. Now this is the values of our new array: 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. Okay, so these are a 2D array. Then that is filter is equals to new array 2 greater than 4. That means filter the array that are greater than 4 for me. Okay, then get me new array that's called filter. Are you guys seeing what is happening? These are Boolean array because I'm putting a test condition now. Don't forget that when you're using these relational operators, your answer comes with as true or false. All right. So I tell you to filter. Watch. I said filter this new array with items that are greater than 4, not equal to 4. So from 4 and above, give me items for 4 and from above 4, that is greater than 4 to the end. Assign them to field. Assign them to what? Field. Are we together? Assign them to field. Then from here, I called this. I just did an index in here. I said from my new array now, use this field to compare my new array and bring out the values for me. If I come here and print field on its own, to see the values in field, look at it. False, 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 true, 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 true. As I said, whatever you introduce here with your relational operator, it comes out in Boolean. That's why we call it Boolean array. It comes out in this. So I'm using this now, this false, 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 true, 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 to filter my array to get the items that are greater than 4. That's why you see we had 5, 6, 7, 8, 9, 10. This is the initial result for the filtration we did here. But I'm not using this, calling it like an index. So telling the compiler that go to my new array and use this filter to check all the values there and give me the result of the ones that are in the position true, true, true. That's why we had 5, 6, 7, 8, 9, 10. Okay. Then we can say, give me the one that is not true. This symbol you are seeing, it means not. Give me the values that are not true, that are false. You run this, you are getting 1, 2, 3, 4. So that's why you filter and you want to check for your array. So that's why I placed, I said, and is equals to our and sign, or is equals to a straight vertical symbol. Now, this symbol, you can find it in your / in your keyboard. And some persons, I think, is in your, the negation is on your, before your 1. But just look at your keyboard, is written, the position is written there. So now this one is greater than, now I'm using a new array 2 is equals to new array 2 greater than 3. So this one is like slicing, using direct, without the filtration. I'm using the direct symbol here now. Don't forget that this one was assigned to field before, but here now I'm not assigning it. I'm just putting the test condition inside the square bracket, inside the index. Okay, I'm using the test condition inside the index. That's why I got 4, 5, 6. So items greater than 3, print them out for me. It's coming out as in 1D array, please. Okay, this is not it's not affecting your two-dimensional array. This is just the result. It's just printing it for you. Is that clear? So now I'm putting two conditions. Here is one condition. Yeah, I'm putting two conditions by using the AND operator. So I'm telling you that take my array, new array 2, then check the values that are greater than 3 and that are less than 9. So I want to get from 4 to 8. So when I run this, I have 4 to 8. Then here, I'm just changing the values. Values, give me values that are greater than 3 and that are less than 13. So I'm going to get 4 to 10. So you can even include the equal to. Use the equal to. These are relational operators included with our logical operators and or not. So I can say, yeah, now I said greater than 3, but less than. I think this is the same thing. Okay. Yeah, I said not. Look at it. I put it in not now. Not greater than 3 and less than, because I bracket it. All of them are in bracket, and negation is outside these two conditions closed in one bracket. So this is the same thing, but I just put a not here by closing the bracket. So now, since I've gotten the values that are greater than 13 and less than, greater than 3 and less than 13, give me the ones that are not less than 13 or greater than 3. So I only have 1 and 13 from my list. Okay, guys, I only have 1 and 13 from my list. So also okay, this one is to just I'm just getting random values here now. So this one is random values, random numbers, getting random numbers as an array. This is it. So also we were taught rand int in class the other day. We were taught rand int in class the other day. So I'm just performing random int in class here, calling the random method and rounding it here. So I'm rounding, giving a random integer number of size 100. Now I'm using this as an M. I'm converting it into an array. The one we did initially was just to find the raw numbers, generate them. But yeah, I'm using them as an array. Okay, give me to 100, then size equals to 10. So if I run this, then I print it, you're gonna see the values 4, 1, 2. So it's random. Just pick random numbers for me. Random numbers, but don't let the numbers exceed 100. But I want a length of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't want numbers greater than 100. So just get me any random number. Now I'm not using this arrange to get from 1 to whatever. Okay, use the arrange, it gets you from where you start to the order, unless you put a step and you'll be getting some steps. But as you can see, it's incrementing ordered. But the random does not follow any order. You can bring the lowest here, the highest here. That's why you see 42, 1, and the rest. 8 is even towards the ending. 45 is 0, 85 is almost at the middle. So this is what random does. Gives you the number. So size is 10. That means the whole size of my list, that is the shape. The whole size, I want it as 10. But I don't want my numbers to, the numbers you are generating, I don't want it to be exceed 100, but just be giving me numbers. So when it got here, I got this. So if I run this again, let me run this again. You can see the numbers have changed. It's not what was there before that is here. I run it again because I'm using the random, so it's not repeating the numbers. I run it again, the numbers will still change. Okay, so I'm now seeing 91, 95. So the more you run it, the more you have different values. Someone say, sir, but this my value was the same. Oh. But I'm running it again, I'm seeing different values because we are running it again. If your might, then I will mute you guys. Sorry. So that's what the random does for you. But if you want to be getting random numbers and you don't want to be changing the values, just change the variable, copy this code, put it somewhere else, and change the variable from random one to random 2 or whatever. So this is the shape of it, dot shape. So I think this was the age we did. Okay, so this was age. All right, guys. So that's all about NumPy that we need to understand and learn. So this is a slicing. Okay, I've already spoke about slicing, so let's leave all this. This is just for you to slice. Slice. So we've already done slicing before. But just know that a slicing operation creates a view on the original array, which is just a way of accessing array data. But the original data is not copied. That's why I said you are slicing, but it does not affect your original data. You don't copy it. You only slice and shows you the output of what you sliced. You can only decide to create it and assign it to a new variable. Then instead you can use np.may_share_memory to check if two arrays share the same memory block or not. All right, so but you don't necessarily need to do that. So all these guys are just all we need to know about NumPy, so that when we are performing operations and calculations on our data sets, we will understand this very, very, very well. So on our next class, we'll be uncovering pandas. Our next class is tomorrow, as usual. So we'll be uncovering pandas, and then we'll move ahead to analyzing big data. So I'll give room for, let me end this live, let me end the recording, then I'll answer some few questions before we call it a night.